Hello and welcome to Cognito Key. Today, we're going to pull back the curtain on a tiny little electronic component that packs a seriously massive punch. Have you ever stopped to think about that? I mean, how does your phone switch between signals so fast? Or how do our massive power grids handle all that voltage without, well, causing problems? Well, the answer, believe it or not, often comes down to this one special little device, the pin diode. And yeah, it's one of the real unsung heroes in the world of electronics, so let's get right into it. All right, so first things first, what is a pin diode? The name itself actually gives us a huge clue. To really get it, we need to break down its unique three-layer structure. So here's the basic recipe. You take a p-type semiconductor layer and an n-type semiconductor layer, but instead of just sticking them together, you sandwich a very special layer right in between them. This middle layer is called the intrinsic layer, and trust me, that's where all the magic happens. Okay, so you might be thinking, how is that different from a regular diode? Well, a standard diode is just a simple PN junction. Two layers, that's it. The pin diode, on the other hand, adds that crucial third layer, the I for intrinsic, right in the middle. And this isn't just some tiny tweak. It completely changes the game for how this thing works. So let's zoom in on this magic middle layer. The intrinsic layer is really the secret sauce, you know? It's what gives the pin diode all of its incredible superpowers. For starters, its size is a big deal. The width of this layer is anywhere from 10 to 200 microns. Now, to give you some perspective, a single human hair is about 70 microns thick. In the tiny world of semiconductors, that's actually a pretty wide gap. And it's this extra space that lets it handle way higher voltages than a standard diode could ever dream of. And then there's its electrical personality, so to speak. This intrinsic layer has what we call high resistivity, about 0.1 ohm meters. Now, in simple terms, that just means it's not a very good conductor. It naturally resists the flow of electricity. And this isn't a bug, it's a feature. This resistance is absolutely key to its job. Okay, so we've got this wide resistive layer. What's the point? Well, this is what allows the pin diode to act like a super sophisticated switch, or even a variable resistor. It all just depends on the kind of voltage you apply to it. So, when you apply what's called a forward bias voltage, these tiny particles called charge carriers get injected into that intrinsic layer. This basically floods the zone, which dramatically lowers its resistance and lets electricity flow right through. And here's the really cool part. By tweaking that voltage, you can control the resistance precisely. It's not just on or off. Think of it more like a dimmer switch for electrical current. But what happens if you flip the voltage and apply it in the opposite direction? That's what we call reverse bias. Well, now something totally different happens. That wide intrinsic layer gets cleared out, almost completely free of any charge carriers. Its resistance shoots through the roof, and it blocks pretty much all current. It basically becomes an open switch. Now, there's a very important term for this. It's called the swept-out voltage. This is the exact amount of reverse voltage you need to completely sweep out all of those charge carriers from the intrinsic layer. Once you hit that voltage, the diode is officially in its off mode, a fully open switch. And you know what? The value for this is usually tiny, something like -2 volts. So think about that. With just a tiny little change in voltage, you can flip this component from being a conductor to a nearly perfect insulator. That is just incredibly useful, right? This amazing ability to control resistance so precisely is what gives the pin diode its real-world superpowers. So let's take a look at where this clever little component actually shines in the tech we use every single day. Okay, so because it can switch on and off in a flash, it's an absolute must-have in radio frequency stuff. You know, like your phone and your Wi-Fi router. And remember that wide intrinsic layer we talked about? That lets it handle really high voltages, making it a perfect rectifier for power supplies. It's even sensitive enough to work as a photodiode, turning light into current. And on top of all that, it's tough enough to act as a protector, shielding delicate circuits from sudden power spikes. But of course, no component is perfect, right? Just like any hero, our pin diode has its amazing strengths and a couple of weaknesses. So let's do a quick rundown of the pros and cons. All right, let's break down these trade-offs. The big advantages, well, that wide intrinsic layer gives it a super high breakdown voltage. It also means it has low capacitance, which basically means it doesn't store unwanted charge. That's what allows it to switch so cleanly at high speeds. Now, the main disadvantage is something called reverse recovery time. Because that intrinsic layer is so wide, it just takes a tiny bit longer to clear out and turn off completely, and that can sometimes lead to very minor power losses.
So there you have it. It might be tiny, but that unique PIN structure makes it incredibly versatile and seriously powerful. It really is a tiny giant, working behind the scenes in so many of the devices we can't live without.
It really makes you wonder, doesn't it? What other simple-looking components are out there, quietly running our world with their own hidden, brilliant designs?
Hey, if you enjoyed this deep dive and learned something new, please hit that like button, share it with a friend who's into this stuff, and of course, subscribe to Cognita Key. We've got a lot more explainers coming your way that dive into the amazing world of technology. Thanks so much for watching.